So 3.5 goes over complex zeros. With these, we're going to be finding the zeros and finding the complete factorization. We're doing the same exact thing that we were from 3.4. Okay, so we're going to solve for x. Those are our zeros. Then we're going to put them in a linear product expression. So if we look at example 1 here, we're given p of x is equal to x cubed minus 3x squared plus x minus 3. We have 4 terms here. So let's try factoring by grouping. So if we take the x cubed minus 3x squared plus x minus 3, and we factor by grouping, we would have parentheses on the first 2 terms, parentheses on the last 2 terms. From here, the first 2 terms we're going to factor out an x squared. The second set of parentheses, we're going to factor out a positive 1. This leaves us with x squared times x minus 3 plus 1 times x minus 3. Those 2 sets of parentheses are the same, so you're going to get x minus 3 from them. Then you have x squared plus 1. From here, normally you're used to seeing this x squared minus 1, which would be a difference of squares, and then you can just factor it completely. However, this is x squared plus 1. It's not a difference of squares, and you cannot factor that further. So from here, if this is equal to p of x, we can rewrite it to where it's equal to 0, and just have x minus 3 times x squared plus 1 is equal to 0. If we were finding the zeros or solving for x, we take that x minus 3, we set it equal to 0. We take that x squared plus 1, we set it equal to 0. For the x minus 3, easy. Just add the 3 over to the other side. We add the 3 to each side, and we get that x is equal to 3. For the x squared plus 1 is equal to 0. For this one, in order to get x by itself, you're going to have to subtract the 1 from each side. So we have x squared is equal to negative 1. From there, we're going to take the square root of each side. And when we take the square root of that negative, we're going to turn it into a positive and bring an I out front. That I just represents that it's imaginary. So with this as well, you're taking the square root of both sides, so you have to include that plus or minus with it. So technically, you're doing plus or minus I times the square root of 1. The square root of 1 is 1. So this just gives us plus or minus 1i, which is just plus or minus I. That I will always go behind the number. So let's say we were taking the square root of 4 or negative 4. We would take that negative out by representing it with the I for the imaginary number. Then we would take the square root of 4, it would be 2. So then it would be plus or minus 2i. So again, your number always goes out front with the I. So you have your zeros here. 1 is 3, 1 is negative I, 1 is positive I. From there, it asks you to find the complete factorization of p. So we're going to do the same exact thing that we did in lesson 3.4 when we were giving the linear products. So if we have x is equal to 3, this would give us x minus 3. If we have x is equal to negative I, this would give us x minus negative I, or x plus I. If we have x is equal to positive I, this gives us x minus I. So if we give this as the complete factorization of p, this means that we have p of x is equal to x minus 3 times x plus I times x minus I. So 2 parts to this question. A, your zeros are just the x is equal to 3, x is equal to I, and x is equal to negative I. And then the second part is that b with the complete factorization of p, so you have p of x is equal to x minus 3 times x plus I times x minus I. For zeros and multiplicity, whenever you have answers that occur more than once, so like if you're given a equation like p of x is equal to x minus 1 cubed times x minus 1 squared, times x plus 3 to the 5th power. You have an answer more than once for these. This is telling you literally that x is equal to 1 3 times, x is equal to negative 2 2 times, and x is equal to negative 3 5 times. So when you have this, you have something called multiplicity, which just means that the answer occurs more than once. So you can state that x is equal to 1 with a multiplicity of 3, or you can say that you have a multiplicity of 3 at x is equal to 1. You can also represent it like it does here, where you have the following zeros are 1 with parentheses multiplicity of 3. You also have the negative 2, that's an answer twice, so that's a negative 2 with a multiplicity of 2, and that negative 3 is a 0, so negative 3 has a multiplicity of 5. With these, this table is literally a representation of the fact that you can look at the highest power in the equation and it tells you how many zeros you're going to have, so how many answers you're going to have. If you have something like a polynomial where there's just a degree of 1, you're going to have one answer. If you look at a polynomial and your highest degree is 2, guess what? You're going to have 2 answers, or 2 zeros. For the degree of 3, you'll have 3 zeros. A degree of 4, you'll have 4 zeros. A degree of 5, you'll have 5 zeros, and so on. So every single time you have one of these polynomials that you're solving or you're finding the zeros for, look for the highest power. That power will tell you the amount of answers you should have. Now, this doesn't represent whether or not they're real or imaginary numbers. They're just answers, okay? So, like I said, the number that's the highest power tells you how many answers or how many zeros you will have for each of these. All right, so for example 4, for A, we have a polynomial p of x with a degree of 4, with zeros of I, negative I, 2, and negative 2. That p of 3 is equal to 25, we're not going to worry about. So we're going to cross this out and not worry about it. What we're going to do with this is write the polynomial with the given degree and these zeros. So for A, we were told that we have zeros, so x is equal to negative I, positive I, negative 2, and positive 2. If we turn these into binomials, think opposite, put it in a set of parentheses with x. So we have x plus I, x minus I, x plus 2, and x minus 2. Now if we set all of this up, we're going to have p of x is equal to x plus I times x minus I times x plus 2 times x minus 2. From here, we just got to multiply. So if we multiply the x plus I times x minus I, x times x is x squared. X times negative I is negative ix. I times x is positive ix. And I times negative I is negative I squared. If we multiply the x plus 2 times x minus 2, we are going to have x times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. And then 2 times negative 2 is negative 4. So from here, we can combine our like terms. That negative ix and that ix are going to cancel. That negative 2x and that positive 2x are going to cancel. So this is just giving us p of x is equal to x squared minus I squared times x squared minus 4. Now with that first set of parentheses here, that negative I squared is the same exact thing as saying x squared minus negative 1. Remember, I squared is negative 1. So when we do this, we're going to have to simplify this. This negative times the negative 1 is going to be a positive 1. So ultimately, we are doing x squared plus 1 times x squared minus 4. From here, multiply. So x squared times x squared is x to the 4th power. X squared times negative 4 is negative 4x squared. 1 times x squared is just x squared. And 1 times negative 4 is negative 4. Combine your like terms. We get a final answer here of p of x is equal to x to the 4th power minus 3x squared minus 4. For example, B, it tells us to find a polynomial q of x of a degree of 4 with the zeros of negative 2 and 0, where negative 2 is a 0 of a multiplicity of 3. So we have x is equal to negative 2 3 times, and x is equal to 0. So when we find these binomials that x is equal to negative 2, think opposite, positive 2, so that's x plus 2. Then again, we have x plus 2 and x plus 2. 0 is neither positive nor negative, so we can just write this as x plus 0. X plus 0 is just x, so when we set this all up as a product of binomials here, we're going to have q of x is equal to x times x plus 2 times x plus 2 times x plus 2. So from here, we're just going to multiply. For the x, we can just distribute it in. We're going to have x squared plus 2x. And then for the x plus 2 times x plus 2, we're going to have x squared plus 2x plus 2x plus 4. Combine your like terms here in that polynomial, so that way we have x squared plus 2x times x squared plus 4x plus 4. From here, we're just going to keep multiplying. So x squared times x squared is x to the 4th power. X squared times 4x is 4x cubed. X squared times 4 is 4x squared. The 2x times x squared is going to be 2x cubed. So I'm going to put that underneath the 4x cubed because they're like terms. 2x times 4x is 8x squared, and 2x times 4 is just 8x. If we add these, we are going to be left with q of x is equal to x to the 4th power plus 6x cubed plus 12x squared plus 8x. So the next part in this lesson that we're going to get into deals with complex zeros and conjugate pairs. What this just means is that when you have something in the form of a plus b times I, you need to realize that you have to find out that conjugate of it as well and use that also. So you're not just using that a plus bi, but you're also going to be using a minus bi. With these, if we look at example 6, it tells us to find a polynomial p of x of degree 3 that has an integer coefficient of and zeros of 1/2 and 3 minus I. Now this 1/2 tells you that it's a 0, and that just means that x is equal to 1/2. You also have this 3 minus I, which means you have x is equal to 3 minus I, as well as x is equal to 3 plus I. So you have all of these to work with. You have x is equal to 1/2, x is equal to 3 minus I, and x is equal to 3 plus I. In order to find what each of these binomials or trinomials are going to be, you're going to have to solve or rewrite these to where x is not solved for. So for that x is equal to 1/2, we're going to move the 1/2 over by subtracting it from each side. This just gives us x minus 1/2. For the x is equal to 3 minus I, we're going to take these, put them in parentheses, and just subtract the 3 minus I from each side. Oops. So this is going to give us x minus 3 minus I. And then for the x is equal to 3 plus I, again, we're going to put parentheses around that, and then subtract it from each side, so that's going to give us x minus 3 plus I. If we simplify these, we're going to distribute the negative, so it's going to give us x minus 3 plus I and x minus 3 minus I. So we're going to use these three in order to multiply to get that polynomial with a degree of 3. So we're going to put this as p of x is equal to x minus 1/2 times x minus, what do we have, 3 plus I times x minus 3 minus I. With these, if you look at these two sets of parentheses here, you have a difference of squares pretty much. So you have this x minus 3 in each, opposite signs, and the I in each. So we can rewrite this as just x minus 3 squared minus I squared. When we multiply this, we got to keep in mind our rules here, so that x minus 1/2 is not changing. That x minus 3 squared is going to give us x squared minus 6x plus 9. And that I squared is just I squared. The I squared is -1. So this is the same exact thing as saying p of x is equal to x minus 1/2 times x squared minus 6x plus 9 minus a -1. The two negatives next to each other turn into positives, so we'll add that 1 with the 9, and we'll have p of x is equal to x minus 1/2 times x squared minus 6x plus 10. From here, we're just going to multiply. So x times x squared is x cubed. X times -6x is -6x squared. X times 10 is 10x. I'm going to put these underneath now. So -1/2 times x squared is -1/2 x squared. -1/2 times -6 is a positive 3x. And -1/2 times 10 is a -5. I combine my terms here. I have p of x is equal to x cubed minus 6 1/2 x squared plus 13x minus 5. If we look at our next example 7, it tells us that p of x is equal to x to the 4th power plus 2x squared minus 8. We're factoring p into linear and irreducible quadratic factors with real coefficients. Then we're factoring completely into linear factors with complex coefficients. So we're just factoring this. We're going to start with that p of x is equal to x to the 4th power plus 2x squared minus 8. We have something that we can multiply with these. We can't take the square root of that -8, so that's not what we're doing here. That -8 is 2 and 4. If the 2 was negative and the 4 was positive, that gives us a positive 2, which is what we're looking for here. So we're going to factor this out to just be x squared minus 2 times x squared plus 4. From here, we can solve for x. If we if we separate this, we're going to have x squared minus 2 is equal to 0, and x squared minus 4 is equal to 0. You can't factor either of these, okay? So move the 2 over with the x squared minus 2 is equal to 0. We have x squared is equal to 2. And then take the square root of both sides. So x is equal to plus or minus the square root of 2. For the x squared minus 4 is equal to 0, we're going to add the 4 to both sides. So we have x squared is equal, this should be a plus 4, so we're subtracting 4 from each side, I'm sorry. So we subtract 4 from each side, so x squared is equal to negative 4. We take the square root of both sides. Now remember, when we take the square root of both sides, that plus or minus goes out front. In order to turn that negative into a positive, we're going to pull out that I, and then we're going to take the square root of that 4. So that square root of 4 is 2, so this is just plus or minus 2i. So we have our solutions here of x is equal to positive or negative square root 2, and x is equal to plus or minus 2i. Now we can go further with this. If we were to take that plus or minus square root 2, if x, is equal to plus or minus square root 2, we have x is equal to the square root of 2, and x is equal to the negative square root 2. If we move these over, we subtract the square root of 2 from each side. Square root 2. This is going to give us x minus the square root of 2, and then we add this one to both sides. And we get that x plus that square root of 2. So we have x minus the square root of 2, x plus the square root of 2. If we do the same thing with that plus or minus 2i, we have x is equal to plus or minus 2i. So this is going to give us x is equal to 2i, and x is equal to negative 2i. So from here, we're going to subtract the 2i from each side and get x minus 2i. We add the 2i to each side. We get x plus 2i. So if we pull this all together, we're going to have p of x is equal to x minus the square root of 2 times x plus the square root of 2 times x minus 2i times x plus 2i. And then that would be completely factored for this one. Look at the last page of our notes. We have a couple of extra examples. For example 4, 5, and 6, we're just writing the polynomial given the roots. So these roots are what x is equal to. So this is telling us, for example 4, 2 and negative 5i. So x is equal to 2 and x is equal to negative 5i. You need to find the conjugate of the negative 5i as well, because it has that imaginary number attached to it. So this is going to give us x, we subtract the 2, so x minus 2, and then this is going to separate into x is equal to negative 5i and x is equal to positive 5i. So we're going to move those over. We're going to add the 5i with the x is equal to negative 5i to get x plus 5i. Put it in parentheses, then subtract the other, and we get x minus 5i. So if we put this all together, we're going to have x minus 2 times x plus 5i times x minus 5i. For example 5, we have negative 7 and 2 plus 3i. So again, this is going to give us x is equal to negative 7, as well as x is equal to 2 plus 3i. Remember, we're going to take the complex conjugate of that 2 plus 3i. So we're not just going to have the 2 plus 3i, but we're also going to have the x is equal to 2 minus 3i. So move these terms over to get them both on the same side of that equal sign. We're going to add the 7 to each side. We get x plus 7. We're going to subtract the 2 plus 3i from each side. So this is going to give us x minus, parentheses, 2 plus 3i. And then we're going to subtract the other as well, 2 minus 3i. So this gives us x minus, parentheses, 2 minus 3i. If we simplify these, this is going to be x minus 2 minus 3i, because we just distributed that negative, and x minus 2 plus 3i, because again, we just distributed the negative. We're going to write this as a multiplication expression, put parentheses around that x minus 2 minus 3i and x minus 2 plus 3i, and rewrite it as x plus 7 times x minus 2 minus 3i times x minus 2 plus 3i. For example 6, or we have 6 and negative 5 minus 2i. So again, we're going to separate this into x is equal to 6, as well as x is equal to negative 5 minus 2i. We can put parentheses around that, but we're also going to have x is equal to negative 5 plus 2i with this one. So that x is equal to 6, that's x minus 6. The x is equal to negative 5 minus 2i. We're going to subtract this from each side, so it's going to give us x minus, parentheses, negative 5 minus 2i. And then same with the other. The x is equal to negative 5 plus 2i. We're going to subtract that from each side, so it's going to be x minus, parentheses, negative 5 plus 2i. We're going to distribute the negative into those complex terms. So we're going to have x plus 5 plus 2i, as well as x plus 5 minus 2i. So we write this all as one product. We're going to have x minus 6 times x plus 5 plus 2i times x plus 5 minus 2i. For our next examples, we're going to be using the given 0 to find all of the zeros of the function. So with these, you have to take into consideration the conjugate of the complex expression that's given to us. Then you're going to have to multiply those out and then use long division. So again, this is pretty much working forward to work backwards to then work forward again. But it's not that hard. It's a little bit tedious, but it's not that hard. So with example 7, we're given f of x is equal to x cubed minus 11x squared plus 43x minus 65. Our 0 that's given to us is 3 plus 2i. You got to think, this is 3 plus 2i. It has an I in it, so our conjugate of it is 3 minus 2i. So you're going to be including both of these when you set them equal to x. So x is equal to 3 plus 2i, as well as x is equal to 3 minus 2i. Move both of these over to where they're on the same side of that equal sign. We're going to have x minus, parentheses, 3 plus 2i, and x minus, parentheses, 3 minus 2i. We're going to distribute the negative for both of these. And this is just going to give us x minus 3 minus 2i and x minus 3 plus 2i. We're going to multiply these out. You could FOIL it, kind of, or distribute the x, then distribute the negative 3, then distribute the negative 2i. However, I see that my x minus 3 is the same in each, so that's like my a term. I have opposite signs between that and that 2i. For each parentheses, that 2i would be my b term. So this is a difference of squares, so we would just have x minus 3 squared minus 2i squared. Multiply these out. The x minus 3 squared is going to give us x squared minus 6x plus 9. That 2i squared is 4i squared. Remember, when you have something in parentheses and it's raised to a power, it's the entire thing that's raised to the power. So the 2 is raised to the power of 2, as well as the I is raised to the power of 2. From here, we know that that I squared is negative 1, so that's 4 times negative 1, which is a negative 4. So you have two opposites here, so they're going to turn into plus signs. So this is just x squared minus 6x plus 9 plus 4, which gives us x squared minus 6x plus 13. From here, now that we have this trinomial, we're going to use this in order to divide. You're dividing what was given to you by this trinomial that you found by using the complex conjugate of that 0 that was given to us. So we're going to take this x squared minus 6x plus 13, and we're going to use long division with that and what was given to us, which is the x to the third power minus 11x squared plus 43x minus 65. All of your powers from highest to lowest are represented. You have a 3, you have a 2, you have a 1, you have a 0, so you're good to go. Ask yourself, that x squared, what times x squared gives me x cubed? X, so I put that on top. I multiply it by that trinomial, so I get x cubed minus 6x squared minus 13x. From here, I am going to subtract. So I'm going to put parentheses around that, change my sign on each of these terms. So this is going to be a negative 3x cubed, a negative x cubed, a positive 6x squared, and a positive 13x. Those x cubes cancel. The negative 11x squared plus 6x squared is 5x squared. And 43x plus 13x gives us 56x. From here, we're also going to drop down that negative 65 and then do the same thing over again. So x squared times what gives us the 5x squared? If we multiplied it by 5, we would get 5x squared. We also multiply the 5 by the negative 6 and get negative 30x. And then we multiply the 5 by 13, get negative 65. This should not, hold on, x times 13. So this 13 should have been a plus 13, which then would turn it into a negative. So when we do this, we're subtracting the 13 from 43, which gives us a 30. All right, so now this works. So plus 30x. All right, so now from here we're going to subtract. So this becomes a negative, this becomes a positive, this becomes a positive. The 5x squared minus 5x squared cancel. 30 minus 30 cancels, and 65 minus 65 cancels, so we're left with 0. So now put all of this together. You have this x plus 5. You had the 2 that you multiplied in order to get the x squared minus 6x plus 13 as the x minus 3 minus 2i, as well as the x minus 3 plus 2i. We set this equal to f of x, and then we're done. So with this, you have to find the given find all of the zeros. So from here, we found that, or we had that those zeros that we started with were the 3 plus 2i and that 3 minus 2i. Then we also found the x plus 5. So if x plus 5 is equal to 0, we're going to add that 5 to both sides, and we just get that x is equal to 5, x is equal to 3 plus 2i, and x is equal to 3 minus 2i. All right, so this should be a negative. This should be a negative as well. For example 8, we're given g of x is equal to x cubed plus 11x squared plus 57x plus 203. Our given 0 is negative 2 minus 5i. So we want to also take the opposite of this, or the conjugate of it, and it's going to be negative 2 plus 5i. So these both are our zeros, which means x is equal to negative 2 minus 5i, and x is equal to negative 2 plus 5i. We're going to move these both over by subtracting them from each side. So this is going to give us x minus a negative 2 minus 5i and x minus a negative 2 plus 5i. We're going to distribute the negative. So we have x plus 2 plus 5i and x plus 2 minus 5i. From here, you want to multiply. When we multiply, think x plus 2, x plus 2. So we're going to do x plus 2 squared. Opposite signs, 5i, 5i. So that's minus parentheses 5i squared. That x plus 2 squared is going to give us x squared plus 4x plus 4. We have a minus 5i squared, which is a minus 25i squared. That I squared is a negative 1, so that becomes a negative 25. So we have x squared plus 4x plus 4. Negative times the negative is a positive 25. We add that 4 and that 25 to get x squared plus 4x plus 29. And now we're going to use long division. So we'll take the x cubed plus 11x squared plus 57x plus 203 and divide it by x squared plus 4x plus 29. So I'm going to put this on the outside. The x cubed plus 11x squared plus 57x plus 203 goes on the inside. So x squared times what is x cubed? It's just x. We're going to have x cubed plus 4x squared plus 29x. We're going to subtract all of this. We're going to switch our signs. The x cubes cancel. The 11x squared minus 4x squared gives us 7x squared. And the 57 minus 29 gives us 22x. We're going to drop down that 203 as well. And then we're going to start all over again. So x squared times what is 7x squared? It's a 7. So 7 times x squared is 7x squared. 7 times 4x is 28x. It's 57. 57, not 51. Okay. This should be 28. And then this 7 times 29 is also 203. So we're going to subtract these, switch the signs on everything. The 7x squared cancel, the 28x's cancel, and the 203 cancel. So we have 0 left over. So if we were to write this out as a product, we would have g of x is equal to x plus 7 times x plus 2 plus 5i times x plus 2 minus 5i. So these give us zeros of x is equal to negative 7. X is equal to, look what they gave you, negative 2 minus 5i, and x is equal to negative 2 plus 5i.